Hello, my name is Shatha and my partner name is Badra from Princess Sumaya University for Technology. Here we will solve two questions. The first one is that we have a gallium MOSFET has the following S parameters measured at VDS equal 3 volt and IDS equal 30 milliampere for 10 gigahertz with a 50 ohm with the following S parameters. Now we will place these S parameters on the calculator and find the delta value and the K value. Here the delta value equal to 0.2 and the K value equal to 3.45. It is greater than 1, which means that it's unconditional stable, so there is no need to draw it. Then we will solve question 2. Okay. Here the question says, we plot the 2, 1, 0 and minus 1 dB input and output constant gain circles for a gallium MOSFET with the following S parameters that we have here. Now we will place these S parameters on the calculator. Now we will calculate the maximum gain for the source and the load. The maximum for the source equal to 3 dB and for the load equal to 1.3 dB. For the source we will draw 2, 1, 0 and minus 1 dB constant gain circle, and for the load we will draw anything which is smaller than 1.3 dB. 1, 0, minus 1 dB will be drawn. We will draw the 2 dB for constant gain circle for the source. By opening the calculator and press on constant gain circles, we will enter 2 dB here and find the radius and the center. The magnitude is 0.625 and the phase is 155. And now we will open Kitab. The phase is 155. We will draw a line from the center. The center, the magnitude of the center is 0.625, so we want to draw it on the Smith chart. Now we will draw the circle. Now we drew the center. We found the center, and now the radius from the calculator The radius is 0.254. Now from the center, we will draw the radius for the circle. Now we will draw the circle. قبليها وبعدين هاي ثانية رسمي قبل ليه ما كانت ما انت لما Now we will do the same for 1 dB. We found that the radius is 0.374 and the center 0.546 and the phase is still the same, 155. Now we draw a line. We want to find the radius, which is 0.374. Now here are the 1 dB circle. Now we want to enter 0 dB and we got 0.471 for the radius and 0.471 center. Now we want to draw the 0 dB circle, and we repeat it for -1 dB. We got 0.556 radius and 0.402 center. The radius 0.556. Now we want to draw the -1 dB circle. And now we will open the calculator, constant gain circles, and we want to enter 1 dB. So we're gonna put 1 dB for the load. The radius 0.374 and the center 0.546. We will draw the 1 dB circle in the Smith chart. By mistake, we put the 1 dB on the source. Now we should put it on the load. The radius is 0.197 and the center 0.484 with the phase 20 degree. Now, from the tools, we will draw the center, which is 0.484. The radius is 0.197. Now from the center, we draw a circle for the road. And now, for 0 dB circle, the radius is 0.405 from the calculator, and the center 0.405 with the same phase 20 degree. We draw 0 dB circle for the load. And now the final circle, minus 1 dB for the center, 0.336. And the radius 0.532. يلا اعمل. Now we will clean the Smith chart. We clean the Smith chart as possible as we can. Now, by opening the calculator, and enter 3dP as a maximum power gain for the source impedance, maximum output power for the source impedance, we got 0.0228 for the radius and 0.706 for the center, with the phase 155. Now for the load, the maximum power gain for the load at 1 dB we got 0.0323 for the radius and 0.509 center with the phase 20 degree. We did this step to get
the matching. يلا
هلا by open كتاب we want to draw the 3dB circle for the source. The radius, the center is 0.706 and the radius is almost 0. We draw the center for the 3dB circle to have the matching. Now we note that the radius is almost 0. So this point will occur the maximum output power. Now for the load, with the center 0.509 and 20 degree phase. اوكي يلا ارجعي. With the radius almost 0. Now this point will occur the maximum gain for the load.
Okay, now we will find the matching for the source and the load. To match the load impedance for the source, following this red circle to intersect the gain circle. So as we go clockwise, we are adding series inductor, and then by following the blue circle, with the yellow color, to reach the center clockwise. So we are adding here parallel inductor. So for the source impedance, this yellow color, by following this yellow color, so we add series inductor, then parallel capacitor for the source. Now for the load, we will follow this line for matching. Now here we add parallel inductor, and then here we will add series capacitor. We want to subtract this value from this value in the Z, and this value from this value in the Y. And same for the source. Now we find the load impedance for maximum power gain and the source impedance for maximum output power.